Okay, let's write a function that returns a dynamically allocated array of strings from a file. We'll include the headers standard IO, string, standard lib, and errno for error reporting. And we'll set up our main function to accept command line arguments. So this function will return a pointer to character pointers. So we'll take a file name, and a buffer length, and we'll store the return count in an int pointer. We'll also write a function to free a string array. This can be used in the load file function and in the main function. So we'll just declare them up here and define them down below the main. So for this function, we're going to need a file pointer, an array to return, strings to put in the array, we'll need to dynamically allocate our buffer since we're getting the buffer length from the function call. We need a line count. We'll initialize this to 0. And we'll set up an initial size for the array capacity. We'll set it at 100. It means that the array can hold 100 strings and we can resize it whenever we need to. So we'll open a file. Open it in read mode. And check if the file open was successful. If it wasn't successful, then we'll send the error to the count variable. And return null. Then we'll allocate memory for the buffer. And this part's optional. Since the size of char is always going to be 1, we don't have to multiply by the size of char. But we'll do it anyway because we're going to be multiplying by the size of char pointer on other variables. So again, if this allocation fails, we'll send the error to the count. And at this point, the file is open, so we'll close the file. And then return null. And then we can allocate memory for 100 strings. So again, send the error back. Close the file. We've allocated memory for the buffer, so we'll free the buffer. And then return null. And now we can start reading the file. We'll read each line into the buffer, whatever the buffer length was, from the file pointer FP. Well, it is not equal to null, meaning there was an error or end of file. Now, fgets only read the maximum of the buffer length characters. So if the line is longer, we need to take care of that. So we'll discard those if it's longer. So we'll say if string char buffer new line equals null, saying there's no new line in the buffer, that means there's more in the file that we didn't get. So I want to get rid of that. So we'll declare a discard char. And we'll read everything up to the new line character. And check for end of file. And we won't do anything with it, we'll leave it there. And we'll want to get rid of the new line character because we only want the string. And what string cspan is going to do is check the buffer all the way up to the new line character and give us a count. So at that position, we'll change that new line into a null terminator. That gets rid of the new line in the buffer. Then we can allocate memory for the string. And this will be the length of the buffer. Plus 1 for the null terminator. Then we copy the buffer into the string. And then we can put the string into the array. and increment our line count. Now if our file has more than 100 lines in it, we'll have to resize our array. Now you can resize the array directly, but I always resize into a new array. So we'll add 100 to our array size. On the second iteration, our array size is now 200. Next, it'll be 300, 400, depending on the length of the file. So we'll reallocate. And we're reallocating array, the original array, and then the same array size times size of char pointer. So if it fails, we need to close the file and free the buffer like we did with the initial array allocation, but we also need to free the lines that have already gone into the array. And if everything's good, we'll point our array to this new array. This will free each line in the array. And this frees the array. So after we're done reading everything, we close the file. We can free the allocated memory for the buffer. Because we have no way to free it outside of this function, we could set the count to the line count. And then return the array. So we'll go ahead and compile and make sure our function compiles correctly. And everything compiles fine, we just get warnings for our unused variables. So let's use our new function now. We'll be taking a file name from the command line, so we'll need to check for that. So to use the function, we'll give it a file name, which is a second command line argument in this case. Give it a buffer length. If we want 100, then we give it 101 because we need the null terminator. And then we can get the count from the address of count. And we'll check for errors. And if there's an error, we can print it out with the string error function. And the error will be in the count variable. If there are no errors, we have the file lines loaded in memory. So we can print them out or do whatever with them. In this case, we'll just print them out. And when we're done using the array, we can free it. So let's compile and see if that works. Everything compiled fine. Let's go back, set this to a -1 to give us a memory error. So first we'll load it without a file name. And since we didn't give it a file name, it tells us how to use the program. Now we'll give it a bogus file name. And it tells us there's no such file. And it also shows us that we forgot a new line on the printf. Now we'll give it a real file name to check the memory allocation. And it tells us we can't allocate memory because we put it to -1 and you can't allocate negative memory. So I'll put this back to 101. Fix our new line character. Save that, recompile. And it works. And we can do whatever we want with the file in memory. If you happen to be someone who likes the word char for some reason, then we can have it give us all the lines in the file with the word char in it. So yeah, that's how you do it. Hope you enjoyed the video. I'll put a link to the source code in the description.